All right, guys. Welcome back. I hope you had a good 4th of July break. After a long time, I took some days off. Actually, I've taken 2 days off at college, so I had like total of 6 days. It was fun, relaxing, and much needed for me. Um, we are entering the last phase of the ACT class. ACT test is on July 17th. So I know many of you are taking the test. I hope you had a good break. Now is the time to buckle up and start studying really seriously because you got to get a good ACT score for scholarships, if not just for admissions. Um, all right, going to open the math packet. It'll be pretty intense 1 hour of math today, so um, page number 10 of the math packet, please. All right, I'm going to give you guys 5 minutes to read through page 10. Very important for SAT, PSAT, and of course ACT as well. All right, page 10. What we're going to do is we're going to get directly started with the problems, okay? You can use that as a reference. So let's get started. First question. Let's go. Find x. These are very typical ACT questions, around 50. In the real ACT test, when some of the students will take the answer choice and plug it back and see which one works, not a really good strategy. Again, the same rule. If you're done, unmute, say your name. So,
Ellie. Arson.
all right, let's get started here. So when you have a problem on powers and exponents, There are many ways to do it. One of the simple ways is to get the bases same. 9 is 3 square raised to x plus 2 is equal to 3 cube raised to 3x minus 1. So there is a rule on page 10, a raised to m raised to n is a raised to m times n. Now we have 3 by itself, 3 on the other side of the equal sign. When the bases are equal, exponents have to be equal. So 2x plus 4 is equal to 9x minus 3. 7 is equal to 7x, x is equal to 1. Well, coincident. Questions? Next question. Convert 8th root of 8 to an exponent. Exponent form.
We just write it? Or do we
Yeah, that's how it was in
Okay.
exponent form.
Did you say it again?
Just so I can get an idea. So. All right, there is a rule for radical nth root a is equal to a raised to 1 by n. So a radical is nothing but an exponent. So 8th root 8 is equal to 8 raised to 1 by 8. So remember, a radical is nothing but a different form of exponent. Without using calculator, what is 8 raised to 1 by 8? Less than 1 or more than 1? Huh?
More than 1, less than 2.
More than 1? Less than 2. Do it. Get your calculators. Do 8 raised to 1 by 8. What do you get?
1.29683.555.
Good enough. Make sense? Question number 3. Solve for m.
Is that 4 in
Is
the...
that part of the problem?
Is that the...
4 times 64 raised to m plus 2. Yeah, it's a part of the problem. let's get started. 4 times 64 is 4 cube. M plus 2. 4 squared. 2m minus 3. So a raised to m raised to n is a raised to m times n. A raised to m times a raised to n is a raised to m plus 1. M plus n, sorry. Anybody matching this?
Did something dumb.
Online?
Mine does. Mine says 2.
So what happened? These two are hardly any different. Yeah.
I tried putting it into twos and it just like did not work.
Well, it will work. It's just having bigger numbers to deal with.
Yeah, it just completely failed.
What you guys have to explain what happened. So
I thought you were gonna do something different than you did.
I did 16 squared.
for 64.
No, 16. 16 squared, you get to 256. 4 times 6.
But yeah, you can't multiply these two because you have an exponent here. So treat this like this first. And that's why I wrote it specifically like that, because I've seen students do that. Question number 4, simplify.
I'm done. I'm done.
Yeah.
Alright, I'm actually going to teach my method, see if you like this. This is actually a really quick one. So let's start with x. There's 5 here, 6 here, and this divided by 3, right? So there's 6 and 3. So you're left with x raised to 3 at the top because this, and this cancel. 6 minus 3 is 3. So why 1, 6, and 7? So you're left with whatever is at the positive stays at the bottom or in the top. So you always want to focus on the positives. Z squared divided by z squared is 1. This is your answer. So let me repeat this. You have 6 x raised to 6 at the top divided by x cubed. That means 6 minus 3 is x raised to 3, which is in the numerator because the numerator side is higher. Same with y's. Y raised to 6 divided by y raised to 7, y at the bottom. Because they have 6 here, 7 here, and z squared cancel. This is exactly what I would do in the real testing. Anybody, any questions so far? Questions, doubts? All right, let's keep it moving. Question number 5. Question number 5. Simplify. All right, let's get started. Log a raised to b is b log a. So log square root x can be written as log x raised to half because square root is nothing but half radical, half exponent, sorry. So that also comes in the front, minus half log x plus 3 log x. Well, log x is common. So 7 minus half plus 3. So it comes to 19 and a half log x. Or 9.5 log x. Or they may also take it back here and write it like this, which is rare, but they sure can. Because remember the rule, log a raised to b is b log a, or b log a is the same as log a raised to b. So both, I've not seen this, I've seen this for sure. Sounds good? Evaluate log 9 base to 8. Log 9 to base 8. Well, there are two ways to do this problem. One is using calculator. Get a calculators. Go to math. Go all the way down to log base. And you get this. And you type in and you get the answer. And that's what I would do in the real test. But let's say they give a problem that it's based on a variable. You can use what's called a change of base theorem. Log a to base b is same as log a divided by log b. So log a to base b is log a divided by log b. Tell me the answer. What do you guys get?
1.056.
1 point?
1.05.
That's good enough. Okay. Make sense? So this is the change of base theorem. Very helpful. Even in college, you'll be using this quite a bit. Make sense? 7. Question number 7. Log x squared to base 3 is equal to 4. Solve for x. So when the variable is with the log, we do what's called anti-log. So in the anti-log, you remove the log and bring the base to the other side. X squared is equal to 3 raised to 4. So this base becomes the base, this 4 becomes the exponent. X squared is equal to 81, x is equal to 9. My first question to you guys is it plus or minus 9 or just 9? Just 9. Why? Because log of a negative number does not exist. Sounds good? So in the multiple choice, they will give 9, negative 9, C would be 9 and negative 9. So you need to be careful with log. Log, you cannot have negative answers. So this is how one method. The other way to do this is you actually do the anti-log last. So log A raised to B is B log A. Then divide 2 both sides. Log x to base 3 is equal to 2. Then you do the anti-log x is equal to 3 squared, which is 9. So you can do the anti-log and then solve it, or you can do the first log A raised to B formula and then use the anti-log. So this is where you use the anti-log. Sounds good? Question number 8. Solve for x.
No.
Don't you think this entire thing can be done in the calculator? Right? You literally do log base of this, then minus log of this, which comes to, I believe it's 4, is equal to log x3. This is anti-log, log cancels, x is equal to 3 raised to 4, 81. Remember, base always stays as base. So this is a base, it stays a base. That's the advantage of having a good calculator, is to do all this in one. Otherwise you have to do the change of base theorem for this, change of base theorem for this, takes time. Sounds good? Okay, questions on page 10? No questions?
I do, but it's on number 4 at least.
Tell me what's the question.
So I understand how you did the x
Mhm.
and how you did the z, because z
Cancels
plus
out.
z, yeah, cancels out. But the y,
Mhm.
so y plus 5 is 6,
Mhm.
6 minus 7.
7 minus 6, because whatever is the bigger number, the other side comes to it.
Okay.
If this is 7,
Yeah.
this is 6, so it comes at the bottom. 7 minus 6 is 1, so that's why y stays at the bottom.
And how? Oh, that's why. Okay.
So I'll always want to make sure the exponents are positive. So if the top is higher, I bring it to the top. If the bottom is higher, then I bring the top to the bottom. Make sense? Okay. Page 11 of the math packet. Conic sections. And we're going to start from circles. So you can represent circle by the equation. The equation of circle in an xy plane So just to differentiate the coordinates of the center point, instead of calling x and y, they call it as h and k. So remember, this is x, this is y. It's just that we represent that way so it stands out as a center point coordinates. And let's say any point on the circumference xy. So the equation is x minus h squared plus y minus k squared is equal to radius squared, which I do not know if you know this carefully. This is nothing but the distance formula of straight line. Remember the distance formula? So the distance radius remains same. So as the distance remains same, that itself is the equation of circle. So x1 minus x2 squared plus y1 minus y2 squared is equal to distance squared. So this and the distance formula are exactly the same. Make sense? For this particular circle, write the equation of circle. Go. Write the equation of circle with center coordinates -1, -2. So in one thing in this particular problem had not given us the radius. Well, you can find radius using the distance formula, right? So radius is equal to square root of x1 minus x2 squared plus y1 minus y2 squared. So this is the radius. So the equation of circle is x minus of -1 is x plus 1 squared plus y minus of minus k is plus 2 squared is equal to radius squared, which is square root of 85 squared is 85. Take your time. Yes? No? Ask questions, guys. This is all kid stuff. If you practice 2-3 times, you'll just get it. You guys are smart enough to know that. You have to practice though. Anybody get this?
I got it.
Okay.
I did.
Okay. All right, I was not planning for this, but I think I'm gonna ask some questions on circles. It'll be fun. And anybody can answer, by the way. What is this line called?
Diameter.
Excellent. What is this line called?
That tangent there.
Is it a sector?
Line. What is this line called?
Sector.
What's that?
Chord.
A chord. Excellent. What is this line called?
That's a sector.
Line. What's the line called? What is this line called? What's that?
Still chord.
it still is a chord, right? All right, listen up. So when two chords meet at the point on circumference with the baseline formed a diameter, the angle of the two chords is 90 degrees. Law of chords. So let me repeat, if two chords meet at the circumference and their base is a diameter where it has been generated from, the angle the chords meet is perpendicular. So that means if the slope of this is x, this will be -1 over x. Guess cool? Online students, is that cool?
Yes. Yes. Yeah.
If I have to pick one topic of weakness of all of you as a general weakness, is your geometry. So, this was not planned, by the way. Just, I think it's going to be helpful. Okay? Good. Next. What is this line? A chord. A line drawn from the center point to the chord at 90 degrees bisects the chord. So this line becomes the perpendicular bisector of the chord. Sounds good? What's the advantage? You can actually build a Pythagorean triangle because this becomes your radius. So this is your Pythagorean you can apply. So the line drawn from the center point at 90 degrees to the chord bisects the chord. Perpendicular bisector. Then you can set up a Pythagorean theorem to solve for the radius or whatever it is. Yes or no?
Ah, that was ugly.
Not bad. What is this line? Tangent. What is this line?
Radius.
Radius meet the tangent at the point of tangency at 90 degrees. If the slope is x, this will be -1 over x again. So what's the rule of tangency? The point of tangency at the radius, the angle formed within that radius and tangent is 90 degrees. What's the advantage? You can set up a Pythagorean theorem again. Anytime with 90 degrees, your first thought should be, okay, I can set up a Pythagorean, or right angle. Yes or no? Sure, so far? Okay. What is this line? What is this line? Okay. When two radii meet they meet at center point, the angle it is formed is called central angle, theta. And the arc it forms, this arc, is called minor angle or minor arc or sector. Well, sector is the area, of course, right? So area is the sector is the area, but this angle is central angle and this arc is called minor arc. Sounds good? And minor arc will be same as theta. So if it is 100 degrees, this is also going to be 100 degrees. Sounds good? And if this is the minor arc, in terms of theta, the remaining is called major arc. So what's major arc will be in terms of theta?
36 minus theta.
Huh?
36 minus theta.
36.
I mean 360 minus theta.
360 minus theta. Good. Because minor arc plus major arc should equal to
360.
or circumference. Cool? Cool. I would spend some time on this actually right now for you guys. Make sure to read through this very well, make your notes on this. This is my biggest concern for you guys. Let me tell you right now, I've been teaching this for a long time. Geometry has been a significant concern of mine. Oh yeah. And especially if you're a junior or senior, I'm most concerned about geometry.
You took it freshman year or whatever.
Yeah, you'll forget it. And you've spent hardly any time on the major part of the second semester of geometry, which is all this stuff. Cool? Online students, any question?
No.
Okay. What is this line? What's this line? If two tangents meet at the same point outside the circle, they are congruent. What is this line? What angle is this? We just did that, right? This is radius, and this makes 90 degrees, and radius are always same. So my question to you guys is, what quadrilateral did we just form?
Rhombus.
Kite.
Kite. Because for parallelogram, it has to be parallel. They're not parallel. And the adjacent sides should be congruent. The major sides are congruent, the minor sides are congruent. So when you form a quadrilateral with tangents and radii, you actually form a kite. Sounds good? But this is 90 degrees and 90 degrees, right? This is my minor arc of theta degrees. Theta degrees. This will be what? If this is theta, this will also be theta, right? Because of the minor arc. If this is theta, what should be this angle?
Theta.
This is 90, this is 90, 180. So these have to add up to 180 as well. So this should be 180 minus theta. Because some of the angles in a quadrilateral should add up to. Yeah, doesn't matter. Sounds good? Yes or no?
Yes.
Because remember, the angles should add up to 360. This is 90, this is 90, this is 180. So if this is theta, this should be 180 minus theta. Good? Okay. What is this line? What is this line? If two chords meet at the circumference, if this angle is theta, this is called an intercepted arc. And this intercepted arc will be 2 theta. So if the two chords form an arc at the circumference, the arc is called the intercepted arc, where the intercepted arc will be double the base angle formed at the circumference. All right, take a 5 minutes break, and Alexa will be here. Stay in here, guys. Don't log off. Okay. See you later. Good night.